Hi, welcome to Common Core Unit 1.2. Well, we're going to talk a little bit about irrational numbers, but to do that we have to backtrack a bit. I know we talked about irrational numbers a few sections ago, but now we're going to kind of come back, a little more of that spiral learning. We're going to be getting to a thing called square roots. If you remember, that's under the irrational tag. But to understand square roots, we really ought to centralize on what exponents are, because they're the reverse of square roots. Well, to understand what a power and exponent is, let me give you a couple of visual examples. I want to ask you a challenge, or give you an idea. What if I were to offer you $1,000 cash, and all you had to do in return was, for every day of the month, I want you to start on the first day and give me a penny. And then every other day you simply double it until the end of the month. Now, whatever you have to pay me. You pay me by the end of the month, and you get to keep the $1,000. So is that a good deal? My $1,000 versus your 1 penny that has to be doubled just until the end of the month. Every day it has to be doubled. Take a second, think about it. What'd you come up with? Well, clearly $1,000 is a lot of pennies. In fact, $1,000 is 100,000 pennies. We're talking about a lot of pennies. So on the surface, you think I'm crazy for offering you $1,000 for a penny doubled throughout the month. So we're like, is that even a question? Well, let's take a look. The first 3 days are simple. The first day you owe me a penny. Okay, and the second day you owe me 2 pennies. So far you've paid me 3 cents. And then 3 days you paid me 1, 2, and 4. So far I made a whopping 7 cents for my $1,000 investment. So far it looks like I'm really lost my mind. But then let's take a look further. We have 1 penny, 2 penny, 4 pennies. 8 pennies, 16, 32, 64, 128, 256, $5.12. I simply changed it to $10 here. $10, 20, 40, 80, 160, 320, $640. Now remember, if we add all these up, you owe me a penny, 2 pennies, 4 pennies. By now you've already paid me the $1,000 back, and we're not done with the month. $1,300, $2,600, $5,200, $10,000, $20,000, $40,000, $80,000. $160,000, $320,000, $640,000, $1.2 million, $2.5 million, and $5 million. So you would owe me approximately $8-9 million. I'll take that in cash or check. Kind of hard to believe that 1 penny can turn into 5 million within 30 days, but that's the power of exponent. Things keep doubling, tripling, and quadrupling, bing, 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 and that's why it's important. Now another example, not as nice, be warned, but is an example all the same. The CDC. Now you might have heard of the CDC from shows like The Walking Dead. They're an actual place. The CDC is the Center for Disease Control. They basically keep things from going crazy with different diseases and problems. When we had Ebola in Texas a few years back, a very small outbreak, they were there to make sure it got contained. They did what they were supposed to do. So the idea that if someone gets sick, the good idea is if you're really sick, please stay home. But if you're not sick, then tough it out and come to school. But the idea is that the CDC looks out for that. Now, one disease to worry about is, in fact, the dangerous Ebola. Now, I've learned a bit since then, so I'm not going to go into the whole thing, but basically it's classified as a Category A biological weapon. In other words, it can wipe out a population pretty quick. I'm going to save you all the different things about it, but at any given day you might see 60 people on a bus, 600 in a school, or 6,000 in a Walmart. And Ebola you can touch. Well, if you touch something, they touch something, the Ebola germs can get on them and they get sick. And within a week they could be dead. So that's a problem. Now, to understand how exponential works and how the CDC works, imagine we had an outbreak, say in Dayton, Ohio. Nothing against Dayton, Ohio, folks. I'm just picking a place. So on day 1, you have 1 patient who's sick. They call that person patient 0. Alright, here's how it works. Suppose that person will be touching stuff that 100 other people might be touching or be exposed to. Okay. So, on day 0, 100 to the 0 power, to understand anything to the 0 power is 1. That's why they call it patient 0. Something to the 0 power is 1 person or 1 thing. So on day 0, we have 1 patient who's sick. That patient touches a bunch of stuff, goes out, does other things. 100, by the way, is just an equation. They might infect 1,000, or they might infect 5, but 100 is the model they might use. So, okay, on day 1 of the pandemic, so 24 hours since, the person who has Ebola, without any sort of contact or without any sort of controls, may very well infect another 100 people. So 100 to the first power is 100. Now, all those 100 people may very well touch and expose another 100 people apiece, and that's where you get exponential numbers from. So 100 to the first power is 100. Where day 2, so 100 to the second power, would be 100 times 100, which makes 10,000. Notice how the circle has grown larger. At first you had this little tiny dot. So you have the dot that grows larger, and the dot that grows larger still, because as time goes on, people are traveling. You may very well have an instance where other people are getting sick. The next day, 100 to the third power, 100 times 100 times 100 is a million. Look at the dot now. It's gotten a lot larger. Notice how little dots have appeared in other places in the country, because people fly, people drive. And again, this is only an approximation. This is just a visual. So by day 3, 72 hours after person 1 has been infected and not treated, or the doctors haven't been called, so if we didn't know anything about Ebola, this would be the problem. And by day 4, you're going to have even more. You're going to have a larger circle. You might have a thing where it's gone worldwide, different spots, because people, again, are flying. The entire country might be basically consumed. And by day 5, you might have all over these giant circles showing overlap of people traveling here and there. 100 to the 5th power is 10 billion people, which is more than the entire population of the Earth. Now, that being said, there are going to be some people who aren't exposed for longer, maybe some people aren't exposed at all. This is just a generic model. And again, I'm not sure Ebola would spread that quick by 5 days, but we're just showing what would happen if 100 people found 100 new people, minus overlap, minus this, minus that. You might have to have 20 days or 30 days to have a huge potential super deadly outbreak. But the point is that this is Ebola that, is, you have to touch, is liquid-based. Now, the fear, of course, is that Ebola can go airborne, which it can't, but if it could, that'd be a real problem. Then exposure would happen extremely rapidly, and that's something the CDC is looking after. And you might see the entire world having that problem. But basically, after the first patient, the entire world was exposed to Ebola. Ebola rates are pretty high. I'm not sure if it's 99%. That was just an estimate I looked for, but it's definitely in the high 90s. So you'd have a death count of about 6 billion people. Something you want to obviously avoid if possible. But the CDC understands exponents and powers, and that's why they're in place. Now, they use a thing called quarantine. In a quarantine, they put it up and say, look, you have to stay in your house. Help will come to you. If they find out you're sick with that, any hospital, they run certain tests, and one of the tests they might run is that they're like, oh, wow, you have that. So they're going to quickly call Atlanta, CDC in Atlanta, and say, hey, we have a problem. We have Ebola, positive Ebola thing. They're like, oh, okay. Keep them there. Keep them there and keep them in their own separate room. Have all your hospital staff glove up, and so on and so forth. So they would basically put a quarantine around that individual, that hospital, all the workers. There'd be things in place to try to control the spread. Day 1, you might very well have to call, and you might have some quick emergency workers, some folks who, might be in the hospital. If they find any more outbreak, they might very well tell people to stay at home, don't go out unless you have to. If it's a real problematic, you might have some military get involved, help keep people, helped out, and supplies come in and everyone behave themselves. You might have a little bit of exposure still in case that person had other people. They might say, well, who'd you talk to? Who'd you travel? Where'd you go? They might knock on some doors and say, hey, how you feeling? Why don't you get in the car? I'm going to check you out anyway, just to be sure. And so they try to slowly contain the virus, and over time, hopefully it burns out pretty quickly. So maybe you might have a death count of a couple hundred or 700 instead of 10 billion or 6 billion or what have you. That's at least the idea. Now again, there's lots of things in play and there's no guarantees, but that's why we pay millions of dollars for the CDC to help look into that. Now, hopefully I haven't scared you into going outside. The point is that it's an exponential equation. Something times itself over and over, and that's how exponents work, and that's how they grow so fast. Let's take a look here. Okay, got 5 minutes left. So an exponent is a way to show repeated multiplication. Now, we've done this before. I want to show you again. You have base and exponent. So 3 squared means 3 times 3. It means 2 3s. Base exponent. All right. So 2 3s multiplied. Okay. 4 to the third power would be 3 4s. Saying, okay, got 3 4s, and they're all being multiplied. You try real quick. So go ahead and write your answer down. Let's see how you did. Well, 3 to the 4th power, I believe, is 81. 5 square is 25. And 6 to the 3rd power, I think, is 216. If I'm wrong, I'll be happy to be told that tomorrow. Go ahead and skip the you try because of time. Skills practice. Go ahead. Try these 6. Write down your answer. Let's see how you did. Alright, 3 times 3 times 3, which I believe makes 27. 6 ones make 1. 2 times 2 times 2 makes 8. 2 to the 8th power. Ooh boy. 2 to the 8th power will. Let's see. 2 times 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 2. 256 what I get. Then I get 16. 9 times 9 times 9. 81 times 9. I get 729. Hope you got the same. Now, you'd say this as 4 to the 3rd power. And this would be 2 to the 5th power. The thing in the corner is what's to the power. This time, just write out in words. Nah, skip that. 2 special exponents. Now, if there's a 2 in the corner, you can call it 5 to the 2nd power or 5 squared. So anytime you hear me say square from now on, that's what it means. And the same way, why is it square? Because on a square, there are 2 sides you multiply, thus the word squared. Now, if you have a thing to the 3rd power, you can call it to the 3rd power or call it cubed. And the reason why you can call it cubed is because you measure 3 exact same sides when you are trying to find the volume of a cube. So why do you say something's a power in the case? Well, 2 to the 5th power just means 5 2's, you work it out. That's the value. It's also called the power. So 32 is a power of 2. Meaning 2 to the 5th power, okay, 2 is what I'm multiplying. 5 of them are being multiplied. 32 is a power of 2, meaning 32 is the result. Somewhere down the line, 2 times 2 times 2 will eventually hit 32. Power means a number that can be written as a product. There are 2 special exponents to know. Anything to the 1st power is itself. So 5 to the 1st power is 5, 3 to the 1st power is 3, etc. And anything to the 0 power is 1. We talked about that with Dave's patient 0 and the Ebola thing. Anything to the 0 power is 1. 55 to the 0 power is 1. 65 million jillion kabillion to the 0 power is 1. So you know. Now what's the difference between these two? Well, -3 square and then -3 square. We didn't really do much with order of operations because, again, this is Common Core. We don't want to do a complete review. Here's the quick version. If the negative's on the inside, it means take 2 -3's. -3 times -3 would make it +9. Where this, the 3 squared goes first. So 3 times 3 is 9. The negative weights to make it -9. Again, for the first one here, 2 -3's make a +9. 2 negatives multiplied make a positive. But over here, you take 3 times 3 and make 9, and the negative waits its turn, and then it makes it 9 after the fact. That's the short version. I'll save you all this reading for later. You try. Go ahead. Tell me what this is going to be, and tell me what this is going to be. Go ahead. I hope you know that this one was +16, because this makes -4 times -4. 2 negatives multiplied make a positive. But here, you take 4 times 4 makes 16. The negative weighted to later attach itself and becomes -16. I hope you got that. You try, skip it. You know it. Although, actually, wait. No, let's not do that. Actually, we will try. Because -5 cubed and -5 cubed. Interesting thing happens here. Notice that the -5, yeah, there's 3 -5s, but if you remember, an odd number of negatives will remain a negative number. Why? Because 2 negatives make a positive, but then you have a positive and a negative, and that's going to make it negative. -125. And here, 5 times 5 times 5 is 125. The negative weights and still makes it a -125. Now, why is it that these are both negative and the other one wasn't? Because this one, it was an even exponent where you're going to have the same number of negatives and 2 negatives make a positive. Where here you have odd man out, and that means that it's going to end up as a negative either way. Got to go because of time. We'll have to do this in part B. Thanks, bye.
To me, tell me your name. You blow me off like it's all the same. You lit it fierce and I'm taking away like a bomb. Yeah, baby.